Hi everyone, it's Will Falcon, creator of PyTorch Lightning and founder of Lightning AI. And today I'm going to show you how to pre-train a model. This is not going to be a toy demo. There will be failures in the video because we will be running out of memory and so on. But we're going to start with the 1 billion parameter model, and we're going to scale it up to hopefully 13 billion across multiple H100 nodes. And then through that process, you learn the principles of how to go to 30 billion and 70 billion and more. And and I'll show you exactly kind of that development process and how to make that super efficient, because that's really where most people spend their time. The last thing you want to do is like kick off a job with like thousands of machines when you haven't done the proper development and debugging, because it's going to cost a lot of money and failed. So one advantage that we have here through the process I'm going to show you is that when you go run on the expensive machines, you've already done a lot of work up front so that it's very time efficient and you're actually using those resources correctly. Today, workflows are super slow because you're kind of coding, submitting, waiting, and crashing, super, super slow. So I'm going to show you how to bypass all that. So we're going to start from a template that we published. So you can come here to Lightning Studios, and then we'll find this pre-trained LLM template. This is Tiny Llama 1B. Again, I'm going to show you how to scale this 1B to 10 billion parameters and so on. And to get started, all you have to do is click here. You create an account if you don't have one, and then this will start up on an A10G for you. You don't need to pay for that because we have credits that are free, and you get about 22 hours per month. And then, yes, if you want to scale beyond that, you will have to buy more credits as you go. So I'm going to go ahead and run this template. And while that runs, I'm going to put this guy on the side here. It's going to take about 30 seconds. And what's happening right now is the studio is duplicating. So we built the studio, we published it, and now when you want to run it, it basically is like taking a laptop and making a full copy of it, right? So it's bringing the environment, the data, the dependencies, the files, everything on there. So it's an A10G. I'm going to wait a few seconds while this thing sets up. I'm going to give you a high level of what this is. Tiny Llama is a research effort. There's a great paper here, right? So you guys should definitely go check it out. So we basically went ahead and replicated all of this. And Tiny Llama is built on one of our open source repos called LitGPT. And it's kind of like we want it to be the seed for projects like this, which is great. And you should definitely check it out. And here, this one was trained on 90 days using 16 A100 GPUs, right? Now, the idea is that you can take a small LLM, 1 billion, and train on a lot of tokens, right? So we replicated this whole thing to make sure you had a reproducible way of doing this. And basically, we got it down to about 4 weeks, right? So this is about a third of the time. But we obviously have to scale up and do way more GPUs, right? So you can do that by scaling more GPUs. So if you're time constrained, you can just throw more compute at it. Sometimes it might even be cheaper because you run for less time, right? So a third of the time here. We also did a ton of work on preparing the data sets. So before we even get to training, you have to take your data and process it and chunk it and do a bunch of different things that make it really, really fast for training. We have studios that do that as well, and I'll show you that in a separate video. But if you're interested, I'll show you which one it is, and you can kind of go look at it. And it's this one here, right? For example, yeah, prepare this data, Tiny Llama 1 token data set. And this studio kind of walks you through the whole process that was used here, right? And so on. So this shows you, it gets it optimized, and then it's ready to go for training, right? Okay, so the studio is running. Before I go through the code, I'm going to actually just give you some more high level. So this is 1 trillion, it's roughly 1 trillion tokens. We're going to go through those tokens 3 times, so 3 epochs. And the data set is about 1 terabyte, right? So at this scale, you gotta actually know what you're doing and optimizing things, or you're gonna burn a bunch of compute. Context size, most models are trained using 2 to 4,000. I believe Llama 2 was trained using 4,000. Don't quote me on that. Check out that paper. And then, there are these like 100,000 context windows and so on. Those are done after training. So there are a lot of methods on how to do that as well, which I'm not going to cover here. So we're going to start with kind of, so when you start the studio, right, it's on an A10G here, and you can see a bunch of metrics about it. Now, I can switch to H100s and other machines in a bit, but first, this is part of the development. Like the last thing I want to do is just start developing this H100. It's like $100 an hour, right? And one advantage of doing that on the studio is I can develop on a very cheap GPU. I would normally use a T4. However, there's not enough memory for this model. This model requires like quite a bit of memory. So I'm going to use an A10G. It's slightly more expensive, but it allows me to debug and iterate and tune the parameters and everything before I go to the expensive GPUs. So I'm just going to start running this thing real quick, and it's going to run out of memory first, right? So I'm just going to open up a terminal here, and you can open up the VSCode terminal here in the studio as well. And I'm just going to type Python pretrain here, right? Okay, so this is going to run this code here, right? And then you'll see GPU metrics and so on. So some things that are happening here, global rank. So this is, and there's one member, so this is only one GPU here, right? These are all the parameters that are being used, and then a few things are going to happen as well, and then we'll come back to them. Now, this is going to run out of memory, right? So I want to monitor this while I scan the code. So you can see the memory usage up there. And we're going to slowly watch this as it creeps up, right? I'm going to put this guy here. Yeah, like this, while I walk you through the code, and we'll see it kind of happen on the side. Like this. Okay. So what is actually happening with this code, right? Let's do this. Great. So up here, we're importing a bunch of stuff. PyTorch Lightning is right here. PyTorch Lightning has the trainer as well. We're not using the trainer here. Instead, we're using Fabric, which basically lets you build your own trainer or your own training loop abstraction. No, we could have done all of this in the trainer, and it would be like 80% less code. But we wanted to kind of put everything into a single file that's flat without abstractions, so that you guys could change all the parameters, everything you want. But ideally, if you're going to keep doing things like this, you're going to have to copy the script over and over again, and then change a few things. And now you fork this like 10 times. So that's not really sustainable. So that's where the trainer comes in, because the trainer just automatically removes most of that boilerplate. And I'll show you what is boilerplate. Pretty much everything here is boilerplate except a few lines. And then we have LitGPT. LitGPT is our open source library with really, really fast model implementation. So GPT here, self-attention blocks, all these like highly specialized blocks that require a lot of engineering. We partner with companies like NVIDIA and Google, and we have our own in-house PyTorch team from former members of PyTorch from Meta and then NVIDIA as well, where we basically will do a lot of work here in partnership with everyone to fuse kernels, to make things super fast. We profile things. So there's been a lot of work invested into this. So these are really, really high performance architectures. And then you can load weights from anywhere on here. So in fact, we're loading weights here, I think from Hugging Face, into the model. Now it's going to be pre-trained, so the weights are going to be random. And then we're going to start like fine-tuning them, right? Not fine-tuning, we're going to start like actually training them. So, okay, so very, very quickly as we keep going down, the model's kind of initializing, and you see that it's kind of getting up there with the memory, right? And if you start looking here, you start to see kind of the warnings, right? So this is running through a validation step right now. So it's running a few batches of validation, because this is just how we coded it. The last thing you want to do is in pre-training, it's going to take multiple months. You don't want to wait like 2 weeks of training before you validate something and then it crashes and then you wasted 2 weeks to compute. So you want to usually validate up front. These are ideas that we introduced in 2019 with the PyTorch Lightning trainer. If you've seen the trainers kind of floating around the open source world, that's where they came from, right? So we created the first trainer. The trainer allowed us to basically introduce this concept to the world of going between CPU and GPUs and TPUs without changing your code whatsoever. And today it's kind of become a standard across other libraries, right? However, the Lightning trainer has hundreds of thousands of hours from the open source community and many, many big companies, including Meta, NVIDIA, Google, etc., that have really optimized it. So it's extremely fast. If anyone's doing any large scale model training today, if they haven't like fully written their own code, which some companies will do, then they're using the Lightning trainer today. It's kind of the de facto for that. So the validation basically gives you insurance that nothing's going to crash because you'll catch it up front. If it does crash, you'll catch it now. I'll catch it in the next few minutes instead of in 2 weeks from now, which is great. Okay, so 1 billion parameters, great. VRAM, very, very close. I can tell you it's definitely going to out of memory because it's so close already to the limit. So in the studios, we give you this limit here. But it's like once it starts the training loop, then the memory is going to blow up a bit, and then this thing's going to out of memory. So then, you probably have experienced this yourself many times. One nice thing about doing this in the studio is that I can just interactively do this and fix all the issues without having to like submit and wait. Okay, so it crashed, great. Now I can see what the problem is immediately here, right? So out of memory, try to locate capacity for 22. Yeah, it's kind of an art to figure out like how much memory to use or not. So I know here, so on this particular studio, I'll give you some hints, right? So some of the hyperparameters you want to tweak, and hyperparameters are, they're like arguments to the model and the file that allow you to tweak the behavior, right? So they're settings for the model and the learning process, right? So you can tweak a few of these. So one thing you can tweak is batch size. Batch size, imagine you have like a bucket of Legos, and that's your data. If you stick your hand in there and you grab a handful of them, that's like a batch of data. You give that to the model processes that, and you kind of do one batch at a time, right? If that batch, when you give it to the model, can blow up the memory because there are a lot of data points in there, then or samples, then you want to lower the batch size, grab fewer and fewer blocks, right? So that's what you'd be tweaking here. Now we have a trick, which is gradient accumulation, where maybe I give the model, I take that batch that let's say I want a batch of 512. Maybe I give it 4, in this case 4, kind of samples at a time, and then I don't compute any updates. I just kind of like let it do the forward pass, you sum things up, and then eventually what you end up doing is you end up kind of like creating 512, a batch of 512, right? But you did it kind of like one at a time. And if you look at the math, it's addition, so you can do that. And then at some point you apply the SGD rule, right? The update rule. So it's just like a math trick basically to lower the memory. So I can tweak this, and I can make the micro batch size like 1 probably here and like not go out of memory. But I'm not going to do that because I know that there's another setting here, and this one's going to be the context window, right? So let me change that context size. There you go. Let me change that and make it smaller, and then and show you that I can actually fit this in the memory. So I believe the instructions are here. There you go, context size. So I'm going to run this here. Okay. So I put that in. Okay, great. Okay, so the next iteration's happening. Now, this took me a few seconds, right? Again, if you're using other systems and like you have different setups, it would take you a long time to do this. Now I'm coding on the cloud, but I can connect my local VSCode if I wanted to, right? So if you're like, oh, but I don't want to code on the browser, then that's fine. Just set up your local VSCode. You copy these instructions. It takes a few seconds, right? I'll set this guy up. Whoop. I've already disconnected from this one. Connect to host. I paste that in there. And in a few seconds, this is connected and I'm ready to go. Right, there you go. Now I'm connected to my studio. And this is my local machine here. This is my laptop. So I can close the browser and it's fine. And I'm here, right? And I can go ahead and change the code. And then you'll see that reflected up here as well, right? If I go to the top now, you'll see that it shows up in a second. There it is. And if I delete up here, it also then shows up on my local machine here. Where are you? Here. So you see how that line was deleted. So up to you. You can connect other IDs, like IntelliJ. There's a new one that people are using. I forget what it's called. But you can connect all of those. But I'm not going to do that. I'm actually going to do this from the browser because I want those metrics. Like something that I don't get on my local is the GPU stuff that I just showed you. These things here, right? Okay, so the new model, the new version is running here, and you see the RAM slowly creeping up. So while that happens, let me continue walking through this code here. So where were we? We were like around here. All the stuff here is around how frequently do you log. This is for experiment management. We're going to be using Tensorboard here, which we can launch from the studio here. And then you've got all these other settings around the learning rates and so on. Learning rate is probably your most important setting. This is pretty much tuned for the 1 billion. So if you go to 10, 20 billion, you're going to have to do a hyperparameter sweep and try it's literally running the script with different learning rates. We have an app for that you can use in the studio as well. You just submit a bunch of jobs independently, and then they'll do that. And I'll show you how to do it in a second. So while that happens, let me actually show you that one real quick. So I'm going to go to hyperparameters, and there's one here. Where are you? Okay, here. So I'm going to duplicate this studio just to show you. It's going to be a separate studio, right? Okay. So I've got this model. Hopefully everything goes well with this one, which I think it should. And yeah, okay. So it's already started, which is good. Yeah, so you see that the RAM isn't going super high. It's staying around 15. And basically, yeah, I just wanted that to start. Okay. So at this rate, it's going to take me 8,000 days. I'm going to let this run for a little bit so that you see roughly like where it converges. I think it'll converge around 6,000, I would assume. Obviously, 6,000 days, that's like 20 years, right? So I'm not going to do that. That's crazy. I don't think this laptop can hold that much video. Just kidding. Okay, so 6,000, 20 years. So we're not going to do that. So we're going to scale it up and make it happen in a few weeks, right? Or even closer. All right, so we just dropped a bunch of time. So this is like to measure the speed of a model, you kind of want to let it get to like a steady state is what it's called. So you see why, because it keeps changing, right? So it's kind of like converging to the estimates getting tighter and tighter the more examples that it sees, right? Okay, so I was showing a hyperparameter sweep, so very straightforward to do that, right? So I could take this code here and just paste it here. And all I'm doing here, in this case, I'm doing a grid search, I believe. Yeah. So I'm grabbing the studio, so it's a pointer to self, this studio here. I'm going to use the studio plugin here, jobs. I have many plugins that I can use for stuff. So I have jobs here. And then I'm going to just search over learning rates. I don't actually need batch sizes. So this is going to be a lot simpler. So I just go through batch sizes. So BS for BS in here. Sorry, LR. Great. And then it's going to be pretrain, the script that I'm going to submit. And then I'm not changing batch size, and the script does not have max stubs, right? So this is it. And then I'm currently using context window, right? Context, what was I using? What's the command here? Context size. All right. So this is the command that I want, right? And then I need to check that there is actually a learning rate argument. Probably is called this. So I'm just going to open a new terminal real quick. And then see what it's called. Okay. Yep. Let's see here. Yeah, okay, there you go. So where's this config defined? see, let GPT config. Okay, got it. Yeah, I don't actually know where this thing is defined, but I assume I can do some. We'll try this in a second, but let me try this real quick. So Python. So again, before you go submit really expensive stuff, you want to test that these things will work, right? So I think config dot learning rate 1e negative 4, for example. Let's see if this will work. If it crashes now, I know that it's not. Okay, so great. See how it crashed? That's perfect. So let me try this. Okay. Let's see, config. Is this gonna work? I'm not super familiar with this CLI thing. Yeah. Let's see, print config. Okay, got it. Yeah, so you would parameterize a script with the learning rate, and then you submit it multiple times. So I'll show you with context size because I know that that one works, and then we'll go. So let's say we wanted to try different context sizes and find the best one so that it doesn't crash, right? So I could try these here. Okay, and I'm going to say context size, and I'm not searching over this anymore, and it's going to be CS. It's going to be just a straight, I'm going to call this sweep and feb 7. Cool. For CX index. Okay, so there we go. And I'm going to use the A10G machine again, and then I'm going to submit this from here, right? So context size, this would be good. All right, so I'm going to run this sweep. So again, I'm kind of sidetracking to show you how you would tune these hyperparameters, right? Okay. Sweep is not defined. Oh yeah, that's right. Context sizes. Great. But see that the beauty of doing this interactive is you can see these errors happen in real time, right? You don't have to like submit, wait, see what happens. So it's pretty much instantaneous. So okay, now this is submitting those jobs, and I've submitted 4 versions of the studio that I'm using here in parallel, or 3, just 3. So I'm searching different context sizes right now to see which one's the best one. I'm really looking to see which one's not going to crash out of memory, right? One of them won't, and it's 512 because I already tried it. So, so I have the 3 jobs. So what just happened here is we took the studio, and even though it's interactive, I was able to then scale it, and basically the environment and everything was forked. So you know how we started the studio by duplicating? We duplicated it multiple times right now, and now they're running on async machines on 3 different machines, completely independent from this machine here, the studio one. So I can do a sweep very easily. And the beauty of doing it this way is that I don't have to set up an environment. It's using the exact same environment, same data, same files, everything, right? Even forks the code so that you can continue coding without changing what's happening in the sweep, right? I don't know why it's called a sweep. I think it's just like a branding name. But, you know, you're searching over hyperparameters, basically. So I'm going to let those guys run. In the meantime, I've got this model still pre-training. Let's see if it's converged. So 5,000 days. All right, not terrible. It's not 8,000 days, but it's 5,000. So, and the RAM's not really a capacity, so I could probably increase that context size a bit and then and continue, right? So let's make this thing faster, right? So how could I do that? Well, kind of the simplest thing is just to go to more GPUs, right? So let's just scale the size of the GPUs here. I want to control C this guy. Let's see. And this is the one, so I'm just going to kill it. All right. And you see the GPU memory gets released. So the job is done, or the studio process is killed. Now I'm going to request 4 A10Gs, and I'm going to switch machines, right? and then we'll go to the H100s. I'm not going to the H100s directly because there's still a lot of tuning I have to do before I go spend a ton of money. I haven't spent too long here. I don't know, 10 minutes probably, 15 minutes, and I've already been able to tune this one A10G, this one model, and then I'll continue iterating on this before we scale it up, right? In the meantime, I'm doing my sweep in 3 unrelated machines, which is great. And let's see what's happening, right? So, okay, I can switch machine. Let me switch machines. So yeah, I don't want you to lose context. So we have 4 machines going on right now. The studio here, and then in parallel, the studio kind of like has emitted multiple jobs, and you've got 3 different jobs running right now as well. And yeah, it looks like they haven't really started yet. I can see the logs as well in real time, and I can see what's happening. And I can see what I'm actually running, the commands and everything else, right? So, okay, and you can do this using your own AWS account, by the way. You can connect all that. You can come here, you can click here, sign in with your AWS account, and then this will actually run on your infrastructure using your AWS credentials. This is really good if you have like AWS credits or you have commits, like you're an enterprise or a startup, then you can easily kind of use that on Lightning as well, and then Lightning's available on the AWS marketplace. So, so I've got those 3 jobs running, which is great, and I've got this fancy GPU machine now. So I'm gonna start this thing again, and this time I'm just gonna run it by default, and I'm not gonna change the context size, right? So notice I changed machines. I'm in a different machine right now under the hood, but the studio just, it's like nothing happened, right? It's even got my command history and everything, right? So I can just kind of press up on my arrow and see what's happening. So I can go between CPUs, GPUs very easily. Okay, so didn't change anything about my code. This is automatically, because it's using PyTorch Lightning and Fabric under the hood, it's going to automatically detect all the GPUs that are there. And on the studio, this works flawlessly as well. And so now we've got 4 GPUs that it's about to start using, right? So I'm gonna bring out that little, I believe, maybe it already has it. Now I'm gonna open a new one here. Yeah, okay. So now I've got 4 lines, great. Okay, so 3 GPUs are up and running. This one's kind of lagging behind. Let's see what happens. And we're going to watch this VRAM go up, right? So I didn't really change anything about the model right now. So I should see some speed ups. Maybe it might even be slower, perhaps. We'll see what happens. Okay, so while this is happening, I've got these 3 jobs running. I know some of these will crash. Maybe this guy won't. This is the 1024, so this one probably will be fine. So let's see where this one is at. VRAM logs. So it's still kind of running. Okay, so it's still setting. Remember, it took a few minutes for like the GPU to like ramp up and do its thing, right? So that's why I rather submit jobs once you've already debugged and done everything on the studio, so that you're not having issues when things go. Okay, so this guy's running, and here theoretically we should be using less memory because we're using sharded parallelism, right? So the kind of layers that I talked about in the video in that previous segment are actually being split across more GPUs now, right? Now I did remove the context size. So remember I had limited to 512. In this case, I believe it's a lot larger. I'll tell you exactly how long it is, how large it is. It's in here somewhere. Let's see. Context. Yeah, I can't really find it, but I'm sure you guys already found it. Okay, if you find it, just put it in the comments. If not, I'm going to go through the code real quick and tell you what it is. So that will be here. Context window, context size 2048. Great. Yeah, so it's about 4 times as much. But the difference now is that this is not crashing, right? So we're like just pushing the RAM here. Like it's crazy. I suspect the utilization is not going to be great because of that. Well, it's not bad. So it's pretty bad here, and then it's kind of like pretty steadily at 100%. So this is what I mean, right? This is a lot of it is due to lit GPT under the hood. I mean, look, we've had engineers at Lightning, NVIDIA, Google, etc., that have spent so many hours like fusing kernels and optimizing things. This utilization is pretty good. It's just like steadily at 100%. Another good measure is power, right? And in one of our profiling leads, he was a TensorFlow before and was a profiling lead at PyTorch before. Did a really in-depth talk, which I'll link in the video as well, into how to profile models, right? And he goes into a lot more depth than I can. But basically, power is also a good measure of utilization, right? So even though utilization may look like it's 100%, a power can tell you more about what's actually happening under the hood. And in this case, it's kind of jagged, so I assume that we're actually not using it as efficiently as we should be. Great. Okay, so now we're at 4 GPUs. So I've actually changed one thing, which is I'm using 4 times the context window. That is like a reasonable, helpful context window. You can go to 4,000, but you'll need a bigger GPU, so we'll try that on the H100s next. And we've dropped the time down a lot. So it used to be like, I don't know, what was it, 5,000, something like that. That was the best we got. So we pretty much made like dropped it in about half by going to for A10Gs. Now think about this. I mean, you guys have heard all this hype around A100s, H100s, this or that. You gotta do your research because like I'm literally doing this with 4 A10Gs right now. If you don't have A100 availability, H100 availability, there are ways for you to do stuff on A10Gs. This is pre-training. You can fine tune I think we let you fine tune 7, is it 7? Yeah, like a 1 or 7 billion parameter model on one A10G. Actually, we can let you fine tune, here, I'll show you. Let me not give you fake news here. Yeah, so fine tune this 1 billion parameter LLM in 3.5 hours. 3.5 hours on 160,000 samples for like $8, something crazy, right? I mean, literally just the same process that I just did. I'll do a separate video on doing this because it's pretty cool. That's it. And you get a pretty good model, right? So like, I don't know why people are paying all this money for all these companies to hundreds of thousands of dollars to fine tune models for you. This is crazy. Just follow these videos, duplicate these studios and run them yourself. Like it's not that complicated, right? We've already done a lot of the work for you. Because we believe that fine-tuning and pre-training should be accessible to everyone, not just a few big corporations. So back to here, 2,200 days, it's continued to drop. This is great. Now, I have plenty of RAM here. Let me see, where am I? Okay, actually, don't have plenty of RAM. Take it back. But we're kind of in a good spot, right? So realistically, you'll do a lot more tinkering here to actually figure out like what is a good size or not. So let's actually take it. Let's actually go up in parameters. So I told you that you can go beyond 1 billion, right? So let's try to go to 2 billion here. And in order to do that, I'm going to change the number of layers here, right? So where are we? Yeah, so number of layers 32. Where is that? Yeah, where's this config coming from? Sorry, I'm like really not familiar with this code. This is here? No, these are logs. Config. Just gonna chase this. You're seeing me debug in real time here. Each params, logger, resume, context size. Okay, so that's where this is coming from. Great. Setup. Yeah, I don't love the structure too much. I do prefer like kind of a trainer setup myself. It's just a lot easier to read. But you know, we'll continue from here. Fabric launch prints, main. Okay, main, here we go. Resume context size. Config from main. Okay, got it. So I think I just do this. Should be enough. Looks like. All right. Okay, yes, that does work. Okay, so there's a little typo there. I'm going to do this, and this is going to be for 2 billion parameters, right? So I'm going to control C this guy. One thing, so you guys try to control C really fast. I've seen it many times in our users. And then what ends up happening is you end up leaving a lot of zombie processes. It's not something that we do. It's something that happens because of multi-processing that PyTorch uses under the hood. And so you see here that these GPUs still have memory for some reason. So that means that there are certain processes that are still allocated. So we just need to make sure that everything's killed. If you get stuck with memory there, I think you can, it's been a while since I did this, but you can basically do this. And you'll see a bunch of these weird processes here, right? Let's see here. So you found, probably not this. You'll see like a dispatch DDP thing. I don't see them anywhere, so it looks fine, actually. Maybe this. Yeah, let me kill this one. And then we'll see if that memory gets released or not. It's common that things won't start for you because you're like, oh, the memory, this or that. So what is this guy? GPU 3. Yeah, GPU 3 is still there. So let's see. I want to see this guy drop. And another thing you can do is NVIDIA SMI, just to verify what's going on. And yeah, you see that there's memory in these two. So, and actually, you should tell me the process, no? There's like something you can do. Let me Google free memory NVIDIA SMI. It's like a very fast. There you go. PyTorch DDP. Yeah, I'm showing you kind of how I would do this. Yeah, they're using PyTorch Lightning. Nice. Oh, it's actually one of our issues. Yeah. So what do we do here? So way to kill these. Clearing GPU memory here. Just restart the kernel. That's not helpful. That's not helpful. Let's see here. I'm sure ChatGPT will have something for you. Okay. Well, let's see if that's already been cleared or not. Okay, I'm just going to keep doing what I know, which is this. Where's this text here? Show you this real quick. Okay. This is not the process name. I forgot what the flag it was. Oh, there you go. Something died, which is great. I don't think it's related to me. Okay, there you go. Boom. So this is why I like coding in the studio as well, right? Because I can see these things in real time. All right, memory's been freed. Nice. Again, try not to edit here, trying to show you reality, what does happen, right? So that's one way to free this up. All right, cool. I used to have like these commands saved. You can save all these. In your studio here, you have this like Studio RC. So you can basically put like commands just like you would in your bash shell, and then aliases and so on, so you can run these. I would put one for freeing up memory in there. Okay, so I've got this thing is free, which is great. Now I can go ahead and run that again, and I'm just gonna run that script. And now we'll validate that it's actually going to be 2 billion parameters. And it'll tell me in a second here. Where are we? Okay, a number of layers. Just want to validate that. Yep, there you go. Boom. So that's correct. So I should see 2 billion parameters soon. And yeah, I mean, this is like also the speed at which these things happen, right? I think it's actually much faster in Lightning Studios, obviously, because like this is happening in real time interactively. And I'm using a very cheap GPU right now, which is great. Normally, probably this would take you a few hours, if not longer, if you're having to submit, wait, crash, submit, wait, crash, right? We built studios this way because we just believe that all of this should be done on the cloud. It's not something that you can really do on your laptop. Okay, great, 2 billion parameters. All right, so tiny llama is now toddler llama, right? And we can keep making it bigger and bigger and bigger. Let's see. I don't think this thing will crash out of memory. But yeah, I mean, that's kind of what it takes, right? So I think it's going to take me a bit to get an H100, so I'm going to request it right now. We give you time estimates here, so 13 minutes. I think it'll be faster. If I get it faster, I'll kill this faster, but you can see what I'm doing, right? So I'm going to keep tweaking the number of layers, number of heads, and embeddings. And you know, we found these through experimentation, and we gave you guys the configs here. You know, it's kind of up to you. Just like if I wanted to go to 3 billion here, right? You increase the number of layers to 40, keep the number of heads steady, keep this steady, and you just keep increasing layers and layers and layers. Now, it's not like you guys should understand. You're not like trying to be like sexy, like number of params, like, oh my God, 100 billion parameters. No, the parameters have to match the size of the data. If you have a lot of data, you need more parameters because you don't want to undertrain a model, right? But also, if you have a little bit of data, you don't need a massive model because you're going to overfit. So your model is going to memorize the data, which, you know, used to be a bad thing, but I think nowadays a lot of these LLMs are probably doing that, and they're claiming they're like doing amazing on these evals, and then turns out they're not. They're just actually memorizing the answers. Okay, so here we go. We had a failure. So out of memory here, it looks like. Let's see here what happened. So I have this. Yeah, I'm going to lower the context window, actually. That probably will help as well. Where are you? Okay, so I'm going to go back to 1024 probably. I just want to get this to work on these four GPUs before I move to the H100. At this rate, like I would be very happy to start training because I've already debugged. I know things are not crashing. I've already kind of tuned the parameters. So now I'm going to go to the H100 and just spend a little bit of time just like really making sure that my GPU memory is up there and then getting that number of parameter count up just to show you guys how that's happening. Again, if you watch in the segments that I did on like the VR thing, I showed you kind of how to think about increasing the number of parameters, right? And it really comes down to like just having more machines. And then there's kind of the newer techniques around pipeline parallelism, right? And there are great frameworks out there that have some of these things, and we work with them obviously to get these things open source and upstream so that all you guys have access to these. And our teams work a lot on those technologies as well, so expect to see a lot of cool things there soon. But yeah, right now we are just going to wait for that H100 and hopefully wait for this thing to happen. So I guess I didn't really cover the whole script. I got stuck here. So we're gonna kind of like back up a little bit here. So I'm gonna continue through the code. Okay, never mind. H100 is ready. So we are pessimistic in our estimates apparently, which is good. All right, check this out. H100. Boom. And I changed, right? So I didn't actually let it finish what it was doing. But you can see how I keep tweaking over and over again. Okay, super important here. Before you go do multi-node, oh, speaking of which, yeah, okay. So see this? I just did a sweep and this failed as expected. And I assume this is a 2048 one, right? Yeah, exactly. So that's too big of a window. Done. Like I already found that. I ran 3 models in parallel. That's a sweep. And I realized that that's not a good one. So this thing is done. These other 2 worked. And then I can just kind of go inspect them. People put the name usually here. So I'm silly. I should have done that. So this is 1024. And I'm just going to look at the estimate here. So 1024, this is going to be 4,000 days roughly. Can't really see the bottom there. And then let's see here. Yeah, definitely put it in the name, 512. And this is going to be a little bit longer. Okay, and the machine looks good. Metrics look great. By the way, you can SSH into each of these machines. So if you want to understand what's happening in this job and actually see it for yourself, you can do this. And I'm pretty sure there's a way to like bind to the Python process and do cool stuff there. So if someone has a link to that and knows how to do that, put it in the comments and everyone else can benefit from it. Okay, so SSH into that machine. So cool. Okay, but in this machine, this is an H100, so pretty sick. I have a bunch of GPUs on here. They're all super idle at the moment, just waiting. And let's look at our beautiful CLI because it's going to make us all very happy by showing this. Boom, look at that. 81 gigs, and there are 8 of them. Great. All right, let's go debug this thing now. Okay, so safe to say that probably I can go much higher here. So let's keep pushing this and see how big we can go, how many params we can go. I'm just gonna run it. How do I want to run this? Okay, let's run it through here. Where was this guy? Okay. And here we go. Let's see what is happening here. All right, so it's distributing itself. It found the GPUs. It's a lot faster, if you notice. Things are just happening much better. The different GPUs have different like architectures. I don't know what, oh, this is Hopper, I think. And then the A10G, I forget what it's called. But they do different things. Like I think the H100s and the A100s all can do like half precision really, really well without issues and probably much, much more beneficial and faster than the other GPUs. We write a lot of descriptions on here, so you can kind of read about the GPUs as well. But yeah, these GPUs are getting better and better, and they have different optimizations. A lot of them have to do with like using different precisions, but doing it in a better way where you're not going to like overflow or underflow, right? The problem with changing precisions going too low is that you may lose accuracy. So a lot of scientific computing may need high precision, but deep learning turns out, like when I was in my PhD, I was told not to use half precision, even though I did a lot of times, because we didn't really know the effect that it would have on the models. I think if I was doing something novel today again and like still trying to figure out if like the research idea is going to work, and for us it's more foundation. So like do we have certain loss functions, contrastive learning, where you're looking at like behaviors of different parts of a model. I don't want variables under like the precision not being correct, right? So I would probably keep it still full precision, but this is a pretty known problem nowadays, LLM training, and we've like discovered that you can go down to like 4-bit and really you won't have issues. So here we go, 3 billion parameters. Again, tiny llama, toddler llama. This is like teenage llama, I guess. And I mean, this thing is massive and lovely, so I doubt this is even going to tickle the RAM on this thing. And then we're just going to keep making it higher and higher and higher. And then we will scale it multi-node. And you guys have gone all the way from knowing nothing about this, or maybe knowing a lot, to starting from scratch. And I showed you everything without edits about how to debug, how to run these things, how to scale them, and then how to do them multi-node and how to validate, how to do sweeps, all that stuff very quickly, right? So it's going to take a little bit for these guys to come up. I mean, this is nothing. Like, this is, I don't really spend a lot of time on H100s because I have a company to run and I have much better engineers than me who are doing this stuff all day long. And they do. And so I've seen them kind of like talk about these things, which is great. And it's been a while since I've trained models myself personally since my PhD. But it's a pretty cool feeling to have a ton of compute that you are controlling and powering through. And, I want to see what all the hype is about H100s. So let's see it. So 3 billion parameters, which is great. What else? Yeah, so I'm going to actually stop those other LLMs that are training. And I'm going to show you how to get the artifacts as well, right? So I'm just going to stop these guys here. And what's cool about Studios is that everything is connected. So those jobs share the same file system as the studio. So I can just grab those and plot them. So I'm going to do that real quick. So I'm going to open another terminal. And this time I'm just going to open it in VSCode. You can do this too, right? And I'm going to navigate up. You see all the other studios in this team space here. And then I see the jobs. And then there I see the sweep that I just started. And actually all of these. So I'm just going to copy all of these. Here. So now I'm bringing all of the artifacts into the studio. And this might take a bit, so I'm going to leave this running. All right. So what's happening? Utilization's not great if you see it up there. I can already tell, right? Okay, so RAM's going up, not bad. So we're at 40 gigs. Cool, cool, cool. $3 billion parameters, not bad. I believe someone on our team got this to like 11 or 12 billion on the H100s here, maybe over the two nodes. I'm using two nodes here because I don't want to spend $200,000 in this video. Just enough to show you guys how to do this at scale. And the difference between one node on Lightning and 1,000 nodes is changing a number, right? Which I'll show you what that looks like in a second. But yeah, really, really not a major difference. Okay, so while this is happening, this is copying. It's going to take a bit because there are a lot of artifacts there. I'm going to just start up TensorBoard as well, right? And then this TensorBoard I can use to monitor everything else that's going on. Okay, so that looks more like it's running now, which is good, I would assume. Yeah, there you go. Okay, remaining time, 5,000 days. Wow. Okay, so it's dropping though. 2,000 days. Look at that. Now we've like kind of cut it in half. Still a little bit slow. Not gonna wait. All right, there you go. 1,800. It's dropping. It's continuing to drop, which is great. This is a 3 billion parameter LLM. So you see how scaling to more GPUs and better GPUs and bigger machines drops the training time dramatically, right? So I'm going to let this get to steady state so it can give me a real estimate of how long it's going to take, right? Okay, so with TensorBoard, sometimes I'm going to have to reload the page. Remember, you could close your laptop right now and like, go home and or take the subway or whatever. And the studio's going to keep running, which is cool. So things can just happen behind the scenes. Let's see what's happening here. Okay, let's run this again. Yeah, I think we're asking a lot of this machine right now. I'm like copying artifacts, starting TensorBoard, right? Usually I would start a separate studio for the analysis here instead of on the same studio. I can just kind of bring over the artifacts to that studio, run TensorBoard there, and then have like a Jupyter notebook or something where I can like actually understand how the model's performing and what it's doing and so on, right? So let's see what's happening here. Okay, startup error. What's a startup error? Yeah, should be fine. All right, while that happens. Okay, 520 days. Honestly, really not bad. Um, that's like less than a year. Well, sorry, less than 2 years, right? Um, so yeah, I'm gonna keep scaling this up. I mean, it's not gonna take me too many nodes to like actually scale this up. All right, 490. So it's continuing. Yeah, it may not start on this because I'm doing so much to the studio already, right? So let's see here. Did we copy all of our artifacts? Yeah, looks like it. Oh, still going. Okay. You can see what happened in the other ones, right? So let's see here. Nope. Yeah, that one crashed, so I wouldn't expect anything there. Either here. Let's see here. Okay, so there you go. So we have Tensorboard events here. I'm actually just going to do that. I did start this other studio for hyperparameter sweeps. I'm just going to use it for the analysis for the Tensorboard and show you guys how to do that. Okay. Yeah. All right. 400 days. So it's getting faster. Are we using all the RAM? No. You still have 20% left. So here's where let's say I don't want to go higher in the number of parameters. So I want to just make this thing faster. I want to cut the days down. So this is a case where I'll probably just start changing the batch size, right? Where are you, micro batch? So I can't, there's no like rule of thumb here. Like I can't tell you that like if I double this right now, I won't go out of memory. Sometimes it's linear, sometimes it's not. Basically, the way to think about it is I have this delta here, which is roughly 6385, so 22 gigs. So you don't want to be right at 85. So I have 22 gigs to play with right now. So I'm going to try to see if doubling the batch size gets me another 20 gigs or if it's too much or not. If I do that, in essence, should be cutting down the training time in half, right? Because I'm going to see the data twice as fast. So let's see what happens there. So Control C. Okay, all the processes were killed correctly. Thank you for not leaving hanging processes. And we're going to set it to 8. And we run again. Boom. 3 seconds to try something new. If you're not using Studios, this would have taken you like an hour and a half, guaranteed, right? Because you're like having to submit, wait, crash, etc. It's a huge problem. All right. Let's see what's happening. Okay, so the copying of all the artifacts happened, which is good. Probably this will work now. Let me try this again. Otherwise, I'm just going to try it on a different studio. So let me just go ahead and install Tensorboard. Okay. And there are no logs here, so I'm going to try symlinking that real quick. There's a ls, an s, and then it's team space, jobs, yep, and I'll just do it here. Okay, so I've got, there you go. And now I should be able to run Tensorboard here. That should work. Let's see. Yeah, there you go. See, now it's up. It's hit or miss. I mean, I'm kind of abusing this other machine, right? Because I'm literally running stuff on it. So I wouldn't expect it to like also run TensorBoard. All right, so there you go. Look at that. So pretty cool, no? Because now I've got on a different studio, I've got all the artifacts and I can actually analyze them. And yeah, it's a tiny window, so I can just do this, open. I've got it full screen, and here we go, right? I believe we logged how it was working, so we can actually see samples. Are these samples? No, these are not the samples I was looking for. I think we logged somewhere. Is in the samples? Like actual text generations from here. So you could see how it's actually like what words it's generating, right? Let me see if I can find that somewhere. Definitely not in scalars. Unless I'm missing something. Nope. And H params. Nope. Nope, nope. Okay. Well, guess we're good. Don't know where that is. Oh, it's on the fine-tuning studio. Yeah, we'll see those in the fine-tuning studio. Okay, TensorBoard's here. You want to share with your friends, copy the link, just send it to them. And this is incognito, so anyone in the world can see this today. There you go. Boom. Open source, free. It's amazing. Love it. All right. So in reality, what I would do now is, because I have the artifacts here, I would like create a Jupyter notebook here, and then just start analyzing, like trying to see stuff, right? Is that right? Python notebook. Can never remember this. I think it's that. Yeah, that extension. Okay. So there you go. You can now start. It's been messing up. Okay. All right. Now you can start analyzing. So this is my analysis studio, and this is my pre-train, right? And these are all grouped under this team space here called tutorials, where I see all of them here, and I can actually see how much I've spent on everything, right? So far I have spent $67 to the cent, and you can see everything I've run here, like itemized, right? So you can control costs, you can set budgets, all that stuff, and you can manage people in here. So you can bring this stuff, add people here. I'm an administrator here. So one team space, every team space is like its own kind of like use case, right? So this could be like fraud model, for example. And now everything that is for that model goes here. And so notice that there's no data here, nothing's been spent, and you have to invite people specifically. So it's like isolation for this. Okay, so back to pre-training. Let's see what's happening since this thing is slow. Okay, so yes, this is good because we were trying to get more RAM out of this. Too much. All right, we push our luck a little bit too much. This thing crashed. I love how sad this looks. It's like wah wah wah, like it goes right above and then boom, just everything comes down. Yeah. All right. Well, batch size of 8, too ambitious. Let's try 6. And here we go. Yeah, I would. I have a few H100s here, so I'm not gonna do a sweep, but like I would just submit a sweep right now for the different batch sizes and just run like 20 H100s independently, one with each model, get the batch size. Most of them will crash. The ones that don't crash, I'll know which batch size is best, and then take that and then actually do the multi-node version of it, right? So that's why a sweep is helpful. Like, don't sit here. I mean, look, if you want to sit here and stare at charts all day, go for it. Like, that's kind of what we all do during our PhDs, I guess. But if you're efficient, you let this train overnight, and then you get the results the next day, and you continue. But yeah, don't look at charts all day long. It's not helpful. Okay, so we got that going. We're gonna wait for this thing to happen. Now I'm gonna scale to multi-node. And in order to do that, I'm going to install this Studio plugin here, right? So lets me do multi-machine training. Studios have plugins, like think of Studio like an iPhone or like a iPad or a Mac, I guess, and they all have different apps here, right? So I have an app here to like view files and like everything that's happening. So everything that we've generated here, I can see, right? So this is like what people I think call like a data lake or something like that, right? And you have multiple ways of viewing this. So these are, we've already generated about, I don't even know how, 6 terabytes, 5 terabytes worth of like artifacts and files. Oh, I see. Okay, yeah, it's because you have tiny llama here. What is this? Oh, tensorboard events. What about this? Yeah, okay, here are the data sets, right? Can we even see Slim Pajama? These are mostly binaries, so you won't be able to see them. If they're like images or anything, you'd be able to see them here. Let's see this JSON, what's in here? Yeah, this may be too big. What's happening? Oh, there's nothing in there? Yeah, interesting. Okay. Star coder. Can we see what's in here? I wish they were just text files, I guess. Oh yeah, no, they're chunked. So this is part of the optimization that we've done. We chunk them all up so that they're really fast. You don't want to have like thousands of tiny files, right? And then star coder data as well here. So, okay, so this view for this stuff is pretty useless. Yeah, cool. All right, so that's one of the apps, right? I showed you the this app here. You can manage the environment here as well. Everything I'm doing here, you can do through an SDK, and then you have all these other things you can do. You can change Python versions, CUDA, whatever. It's, again, your laptop. Mess it up, you know, and then start a new one if you screw it up. Okay, so what happened? What is going on? Let's see. All right, 3 billion parameters still, and it's continuing to instantiate a model. 96 seconds. Okay. I will end with multinode, but I just want to show you guys what happens in reality, right? We don't really look at these other things. You like if you hadn't optimized a data set, right, which you need to watch the other video to know how to do that, then you probably would be looking at like your let me create a new chart here. You can pretty much double click anything Lightning to make a comment in its own window. You would look at like disk IO networking, right? And right now there's actually nothing happening because the model's just kind of being loaded. But you should see networking and the disk IO go crazy as soon as we start training, right? And then if you don't saturate your network, like your networking fast enough, it means that your pre-processing was not great. And so it's like having like imagine the GPUs of Ferraris, and it's like having 1,000 Ferraris in the middle of Manhattan. Like they can't do anything, right? So like you need to have really, really high performance data streaming, all the things that we're doing here to pre-process the data. It gives you like a 20x speed up. So, the 5,000 days or whatever this is going to tell me now, 500, maybe 300, it would be literally like 20x that if you hadn't done this, right? Most people don't know that. They think it's all about training. No, you got to optimize the data. You got to process the data as well. The platform lets you do that. We have apps for that, right? There will be other tutorials on that. So here we are, and I'm hoping, okay, so the spike happened and we didn't out of memory. So I'm hopeful that 6 does work here, which is great. Okay. Stop going up. What's happening? Okay, I'm not hopeful anymore. If you can't make changes to your code this easily, you're using the wrong framework. Yeah, I don't know. I said it. The whole point of PyTorch Lightning and everything that we do is the fact that you can change everything and hack it all and make it all your own, right? So if you find yourself not being able to like control things and make changes, then I would suggest you look at LitGPT, start there, or literally just start at this studio, run this, and then you got to walk before you can run, right? Learn how to do this stuff first before you try to go change all these things about it. And if you're an expert, then you would love LitGPT already because you have all these crazy strategies. We're using sharding, but there are other strategies that we support as well. Okay, so this is moving faster, I can tell already. We're like right there in terms of memory, right? So here we are. I made this faster now. I'm hoping, right? I think I did. And yeah, It should be 50% faster in my opinion. So the last estimate was like 500, was it? For something, for 80 is where we converged. So I would expect this to be somewhere around 300, 350. Let's see if I'm totally wrong, because I increased the batch size quite a bit. Well, not quite a bit. I come from computer vision where batch sizes were like thousands of samples. It's crazy to me that in NLP we don't use many samples, but you know, it's where we are. It's, it is what it is, I guess. Okay, 540. Yeah, I do think it's going to keep dropping. So it is already faster, and we haven't really hit steady state yet, right? $490 keeps dropping. Great. Okay, so I'm going to let this keep dropping a bit. So what I wanted to talk to you about is what I'm tweaking right now is assuming that I want a 3 billion parameter model, how do I keep making it faster and faster and faster? So I'm not changing the size of parameters now. It's already locked at 3. Now I'm just tuning the batch size and probably the learning rate in it to basically get it to be as quick as possible. And now I'm going to start scaling across more nodes and add two nodes. Every set of machines that I add should basically, you know, if you've set everything up correctly, cut training time in half, right? So that's how we measure performance on our platform. When I add two machines, let's say that this stopped at 420, right, or 400. If I add two nodes, I expect it to go to 200 days, right? Now it may not work that way depending on how else you change other things, but if I keep everything steady, I would expect that. Then if I go to 4 nodes, 4 machines, I would expect it to be at 100 days. And if I go to 8, 50. If I go to 16, 25, and you can see how you get it down. For example, when I was at Facebook AI, a lot of the stuff that we were doing was contrastive learning. And, you know, this is how PyTorch Lightning was born and how scalable training kind of came about from a lot of the work that the PyTorch team and other teams were doing internally, and we put it into the open source, was training on image nets. And back then, I think when I started that project, it was taking about 3 months to run through this contrastive learning algorithm. And you know, a few months later, after having built PyTorch Lightning and work with the team internally, it was down to about 2 minutes, right? Which is really fast. But it also needed 2,000 GPUs. And Facebook GPUs are great, and they're all connected and stuff. Or Meta, sorry, they're all connected and they work really well. So it's a lot of these tweaks that you can do, right, to make things faster. Okay, so I wasn't totally off. So we're at 360 right now. So it's less than a year now. And yeah, now if I don't know, I think it'll converge. It'll get to steady state around 330, 340. So I would probably leave this running for a little bit. I mean, at this rate, like this model's ready to go. Like I'm ready to scale this thing. Like I don't need, I want 3 billion, right? I can keep going. So I'm gonna save these parameters, and then I'm gonna run this on 2 nodes, and just to like cut the time in half, and then show you guys that, right? Now, if I want to keep increasing number of parameters, then I will drop micro batch size probably to 1. That gives me a lot more RAM, and then I can actually go bump up the number of layers here, right? So I can say, give me like 80 layers. So let me do that for 1 second before I go scale this thing up, just to show you what I mean by this, right? Okay, super fast iteration times, love it. Here we go. I'm not looking at the networking, it's fine. So what did I just do? I doubled the number of layers. So I expect this to be like 6 billion parameters right now. And then I lower the batch size to 1 to basically release as much memory as I can to allow for more parameters, right? It's also going to be a lot slower because you have more parameters, right? But let's see what it tells me the size is going to be now. So if I'm right, it should be around 6 billion. Yeah, I need to check on the jobs. Okay, great. So the jobs were stopped. And I've got this analysis studio running. As long as you're running something in the studio, it will not turn off by itself, which I have Tensorboard running. But I'm going to go ahead and just turn it off so that we don't waste that compute. Okay, so we're good there. All right, before we start before we start scaling to multiple nodes, I'm going to show you what this means, right? So you have the multi-node app here. You remember how I submitted jobs? I didn't have to do anything else. It's the same thing here. I just need to select the script that I'm going to run. Okay. And in this case, it's going to be, where are you? It's not the sweep one. It is tiny llama. No. So it might take a second for this to show up, for the files to be visible here. So we'll give it a little bit longer. Where are we? Yeah, we're looking for pretrain.py. Although I don't need the file to show up, but I kind of always like, having the certainty there. Okay, so I'll give it a few seconds to continue to show up. And then maybe I'll do this real quick. Yeah. Now, if you're not doing what I'm doing here, if you're curious about other techniques, this multi-machine training app for the studio has different templates you can use to test different things, right? So if you want to see how to do it in plain PyTorch, here it is for DDP. Now, it is very complicated to get this stuff to work at scale for like things like FSDP. FSDP is what we're using right now to scale this model. And then you can use DeepSpeed as well, and the templates are here. And you can, and I can show you, for example, PyTorch Lightning. It's a lot easier to do this stuff. So FSDP and PyTorch Lightning, notice it's a few lines of code. It's all the code that's here, it's like computational code, computational graph stuff, right? And it's super clean, super neat. And everything else is calm. All this like gradient accumulation, all this stuff around like, if you look at this code, there's like all these parameters, there's like all this policies and setting things up. And most of this stuff is it's boilerplate, right? That stuff, it's already been automated. So that's inside the trainer. So, okay. So let's see here. All right. So not totally wrong. This is 5.6 billion parameters now, right? So how did I get there? Remember, I doubled the number of layers and I dropped the mini batch size or the micro batch size to 1 to free up more memory for more layers, right? So kind of the trade-offs you can make. Not quite sure where the VRAM is going to end up. Could be nowhere good, and then this thing will just crash. But now I've gotten this to be 6 billion parameters, right? So that's great, and maybe I'll even scale this to multi-node. Why not? Well, no, I want to continue with the 3.1 that we were using, and then if you remember, the time estimate was 320 days. So I'm going to cut that time estimate in half at least by scaling it to multiple nodes. In the meantime, I need to get this file here. Okay, there it is. Nope, there's not it. Okay, so it's fine. I don't need the file itself. I can just do this main.py here. No, that's not what it's called. It is called pretrain.py. Okay, so I'm going to revert my changes. So 40 and then 6. So this is kind of what worked. By the way, if you're using Git, just use Git. There's nothing special you have to learn to use Git on Lightning Studios, right? Right, this is not a Git repo, but I've already logged into Git and everything on my studio, so I can just git clone anything and commit and do whatever you do on your laptop, right? This studio just, we didn't put it under Git control, mostly so that you guys have clean code without any of these other dependencies. Okay, where are we? Yeah, undecided if I want to go for 6 billion or keep it here, 3 billion. Let's see here, 1,200 days. Okay, so not totally out of memory here. It may not be terrible. Let's see what happens. Yeah, okay, for brevity of this video, I'm not going to try to, I don't want to wait for this thing to get to steady state because it's going to take a few more minutes. So I'm just going to scale up this one. This is going to be the 3 billion one, right? Mini batch size of 6, and then 40 layers here. So 3 billion. So it's going to give me, and it's 320 days. 320 days. I want to cut it in half. So now I'm going to submit that job, right? And let me just go ahead and Control C. We'll kill this. Make sure everything gets released. Great. Okay. And now that it's all ready to go, now I can go and do the expensive thing, which is multinode, right? And there's nothing I have to put in the script, so I'm just going to pick pretrain.py, and that's it. This is as easy as multinode as in Lightning. Pick the machine you want. I'm currently on that H100. You usually want to use the same machine because you need to debug and make sure nothing failed before you go scale, right? This is one massive advantage you have on Lightning is debug on the same exact machine with the same setup and everything before you go scale it up. And you know, if you want to go to 1,000 H100s, you change it here, right? So here, this is going to be 64 H100s right here, right? This is going to be 32 H100s and so on, right? And you can type a number and, you know, we'll scale that up for you. Now, we will warn you when you are probably not going to get those machines as well. So there are wait times, of course. But the beauty of this here is you can leave this thing, let it be queued for a while. Okay, so I'm gonna actually just scale to 2 nodes. So this is gonna be 16 H100s on 2 nodes. And what I'm looking for is to drop that training time in half from 320 to 116 or whatever. And this is the pre-trained script, not what you're seeing here. That script is just not showing up here for some reason, but it's already available. Okay, so I submit the job. Boom, great. This is a high-level view of the cluster, the 2 machines. Now I'm gonna leave. I'm done with the studio, so I'm gonna switch back to an A10G, and that way I'm not burning money. Okay, so I'll give it a second. Yeah, this is my favorite part about Studios is the ability to debug in real time, interactively, and then scale it up, right? Okay, so if you look at the kind of cluster here, you see that we are waiting for these 2 machines now. So everything's been registered. All right, so I'm switching. I am now on an A10G. So this H100 is back in our availability pool, which is great. And now I'm on an A10G. And this way I can debug and kind of see what's going on. I can also switch to a CPU since I'm not interested in continuing to run this. And yeah, now I'm waiting. Looks like the cluster's up and running, the model's starting to run, and I can very quickly see that the RAM is coming up. And so everything looks promising. If we look through the logs, then, okay, so it's already going. 3 billion parameters, love it. And everything's getting set up. So let's just wait and see how things evolve. Once the RAM is at full capacity, then I will know that you know, the model's kind of loaded and everything's ready to go. I'm looking for the training time to go down a bit from 320-ish days to roughly half that. And then depending on how much RAM I have left at this point, then I will likely add more batches and then I will resubmit the job again and then keep doing that until I scale and get to the level that I want. And yeah, that should be pretty straightforward, but now it's a lot faster to iterate because I'm just changing 1 or 2 parameters at a time. And the way that Lightning works is the machines will kind of stick around after, so you don't have to wait around for them to restart. You just kind of put the work on there and then keep iterating over and over again. So it should be a few minutes. Maybe the first time they come up might take a bit because you would have to allocate them, and depending on how many users and how much usage is happening, then you have to wait for those machines. But once they're ready, then they're yours, and you just keep iterating on them. So let's see what the RAM is going to do. Okay, this is probably the last jump, I would assume. So we do still have some room. So I would probably, never mind, we don't. Yeah. So in this case, actually want to know context size. Guess it would be in the logs here. I don't actually know where we logged it. They'll be logged to an experiment manager most likely. But I believe it's 2048 here. Okay, so you see the time is quickly dropping. So this is cool. The system's running. And I can go into each machine independently and see what's happening there. So in this one machine, I can see VRAM, it's kind of going, utilization, etc. Right? Power, and I can SSH into every machine independently. So I can see what's happening here. Yep, and kind of the same stats that we're showing everywhere else. So all looks good. You can, I think you can like bind to the process somehow and like inspect things if you needed to. Here we go. So just super curious to see where the RAM lands. Yeah, it's good. No out of memory. That's like 90% of the battle. Okay, yeah, pretty quick already. We're already at 340. So we will keep iterating. And it's only at step 14, but it's already much faster. You can already tell. And and the more iterations it goes through, the faster it gets to steady state, and then the more the more accurate this estimate is going to become, right? But you see, it's very straightforward once you've set up everything, right? And I think one of the hardest parts is getting everything set up. So that's why starting from a template studio is super helpful because we've already done all the work to get all the, nooks and crannies ready to go, all the pieces. You have full access to the code, so you can really own it and switch and tweak things to your advantage. And yeah, so I'm just gonna let this run for a little bit and see what happens. So 250 days. Like I said, I'm looking for about 120, 130. We should probably get there, probably in a few minutes as this thing continues to iterate. And then yeah, that roughly will get us twice as fast as where we were before. So let's see here. Temperature, power. So this one looks pretty good, I have to say. So this one does look more kind of saturated, right? We have these gaps down here that are not great. So we would have to look at them. And utilization's getting much better, of course. So there's like all of this setting up that's happening. There's like the learning rate decay and all these different things. So this is getting more to like the steady state and then the constant GPU utilization. At which case we'll have a much more clear estimate of how long it'll take. Okay. Yep. So it's already 30% faster at least. And I do presume that this will end up landing at around 140, 150. So I'm going to let this run for a little bit, and then we'll see where this converges in terms of speed. Okay, so the estimate keeps dropping, and we're already at 158. So the last one was 320, kind of where we left it, right? So this is already twice as fast, basically. Now, I don't know if 320 was steady state. It could have continued to go down, but it was pretty much converging at that point. In this case, it also feels like it's converging, but I would assume that 150-ish or something is where we end up here. So by scaling on two nodes, I was able to make it twice as fast. Now, in this case, the memory is still pretty much max, so I'm not going to be tweaking the, yeah, I'm not going to be tweaking any more parameters at this point. I'm just going to be simply scaling more and more and more nodes. So if I go to 4 nodes here, I can expect that the time to be twice as fast and so on. Anyways, so again, all of this started from our pre-trained tiny Llama Studio, which I encourage you to go run yourself. And basically, this kind of walks you through everything that we just did. And as a summary, we duplicated that in about a minute or so. We then tuned it on one A10G. Then we scaled it to four A10Gs. We tweaked a few hyperparameters to make the model go beyond 1 billion parameters. Then we went to an H100 where we actually started tuning it before we started doing the multinode training. We submitted a job for multinode training. We also did a sweep in between to figure out a good context size. We submitted a multinode job with two H100 machines, nodes, and now we're in the process of just trying to make it faster and faster by scaling across more nodes. So that's the workflow in a nutshell. Like I said, it's straightforward. Don't be afraid to try these things on your own. Fine tuning is a way simpler problem. It's very similar to this, but the iteration speeds are much faster because the model is using less memory usually, and you have a little bit of data, so it'll be done in a few hours, right? So I'll do a separate video on fine tuning as well. But anyhow, I hope this is helpful. Thank you guys for watching, and excited to see you in the next videos.